Hello, everybody. Welcome to another video in our Introductory Data Preprocessing workshop. So last video, we've talked about non-useful data and how they can increase computational overhead. Well, in this video, we're going to be talking about feature manipulation. So I want you to understand a difference between words versus numbers. Machines are great at interpreting numbers. Humans, on the other hand, are great at interpreting semantics and meanings of words. But your computer is not a human, so it doesn't know semantics. So one thing that's really important in data preprocessing is making sure that features that are like textual and words need to be somehow numerized, right? We don't want them as categorical attributes. We just want to numerize everything because computer understands number. So let's dive into this. So we're going to take the name, sex, and cabin columns as shown. We're going to print out the unique values for the name column, the sex column, and the cabin column. So you get the unique names right here, the unique sex, male and female, and the unique cabin column right here. So we want to encode these values somehow. One simplistic way is just match each feature to a value. So if you had a feature for male and female, you can match male to 1, female to 2, etc. Another smarter way generally is to do one-hot encoding. So we can turn each feature into a set of binary features. And you'll see that more in the example, so it'll make a lot of sense then. So find and replace is a technique where we are essentially looking for entries and replacing them, right? Just like you do in Control F. So we're going to read the CSV file, our Titanic dataset. We're going to take the distinct values for embarked, so take the unique values. You'll notice from earlier that you have NaNs in the embarked column, right? Let's deal with the NaN by replacing it with Q. So all NaNs are filled in with Q through the fill now function. So you'll see SC and Q are the unique values for the embarked column. And we're going to build what's called a cleanup dictionary. So for the embarked column, we're going to map S's to 1s, C's to 2s, and Q's to 3s. And we're going to call replace. And what you'll see here is when we go to the embarked column, right, we'll see 1, 2, 1, 1, 1. And you'll notice that 1 maps to 1 was coming from the key of S, 2 was coming from the key of C. And you'll see here you'll have SC, SSS. These map to 1, 2, 1, 1, 1 respectively. So you know that this replace is working. So that's find and replace. We can even do something called cat codes, right? So we can take a column, define it as a categorical type, and then essentially assign a number to each unique entry in this category, right? So we'll take the P class, make it categorical, and then call cat codes to essentially get a number assigned to each unique value. Kind of similar to clean nums, except this numerical assignment is done for you instead of you specifying the numerical assignment. I guess one thing to think about is what is the problem with the cat codes approach? I'll give you 5 seconds to kind of think about it. Post your response in the comment so that other people can, share your insight. Hopefully you had time to think about it. So let's move on to one-hot encoding. So one-hot encoding is a very popular way of, binarizing and kind of encoding your categorical data so that computers understand numbers instead of just words, right? So what we'll do is use a function called getDummies, and we'll take in the data set, right? And we're going to take in the columns that we want to kind of binarize. So we're going to take in the P class, the sex, and the cabin column. So if you recall correctly, right, P class from our original data frame, right, has, the values of 1, 2, and 3, right? So what we're going to do here, or actually it became 0, 1, and 2 now that we have done cat codes, right? So what we'll notice here in this data frame is if you look at the P class column, right, we're going to have a P class 0, P class 1, and P class 2, right? And for each row, let's say you have a record that was P class 1, or P class 2. Then P class 0 will be assigned 0 because it's not P class 0. P class 1 will also be assigned 0 because that record wasn't P class 1. But you'll assign a 1 to a record that's P class 2 because it is true that that record was P class value 2. So you'll see here that in this one-hot encoding scheme, for categorical values where you can take on only one of the possible values, you'll see here that a 1 will be attached to the value that the record is or what category value it is. So that's what this P class is doing. You'll see something similar for sex, male and female. So either passenger is a male or a female in this data set. So you'll have 1s if a passenger in the sex female column, if a passenger is a female. You'll have 1s in a column for sex male if a passenger is a male, but you won't have a 1 and a 1. So that's what a binary encoding is doing. And that's why it's called one-hot encoding. So one value in a category is 1 at a time, where everybody else is 0. That's called one-hot encoding. And you'll see something similar for the cabin column. So that takes care of one-hot encoding. Until then, I can't wait to see you in the next video. Thank you and have a good rest of your day.